Welcome to the Sizer online tutorial for the US edition. In this tutorial, we will demonstrate the various inputs in the beam input view of the Sizer software. When designing beams in Sizer, there are 3 span types available and the results are going to change depending on which one you select. In this case, we will discuss the behavior of a 10 feet single span beam. The first one, design span, which is selected by default when you first open a new project file, means that the length of the beam will be defined as the distance between each center of points of bearings. Therefore, the resulting length of the beam would be 10 feet plus half the bearing length at each beam support. When selecting clear span, the span length specified will be the interior distance between each point of bearing. Again, after the design is run, this span type will result in a beam length that is longer than 10 feet. The length of the beam will be 10 feet plus the bearing length at each beam support. Finally, when full span is selected, the total length of the beam including the bearing length at each support will be 10 feet. So, depending on the span type and bearing options you have specified, the beam length is going to change when you run the design of your beam. You should pick the span type and bearing details which are most suitable for your specific application. If you leave unknowns for the bearing length at the supports, regardless of the span input choice, each of the span type dimension will be shown in the beam diagram with the word unknown, as the dimension cannot be established until after the design is run and the bearing length is determined. It is also possible to define multiple spans with a limit of 6. Doing so will automatically generate interior bearing support. Note that the span type definition we have just talked about also applies for the new bearing support. Once more than one span has been added, the option to define a cantilever will become available. The software allows you to specify cantilevers either on the left side, right side, or when you have 3 or more spans, on both sides. For beams or joists with cantilevers, Sizer determines the cantilever deflection limit by taking the specified deflection limit and assigning the span L as equal to twice the length of the cantilever. This is consistent with most model building codes and industry recommendations. The software also permits you to ignore cantilever deflections in the design from the Design Settings tab. In Sizer, 5 types of elements can be selected depending on the function it will fulfill: beam, floor joist, roof joist, floor panel, and roof panel. The main difference between roof members and floor members is the default deflection limits associated with them. In fact, for roof members, the deflection limit under snow load is their member's span length divided by 240. For floor members, the deflection under live load has a stricter limit, the member span length divided by 360. Depending on the type you have chosen, it will limit the options of materials, species, grade, width, and depth. With the exception of option for material, it is possible to leave all these other inputs as unknown, and the software will provide a list of member species and sizes which will resist the applied loads when the design is run. Ultimately, you can choose specific member types that you know are available in your area. Sizer also allows you to input custom section sizes for the depth and width, which are not necessarily listed in the depth or width drop-down list. Note that if you are using imperial units, the nominal dimensions are listed, but the actual dimensions are used in calculations. To summarize, in beam mode, it is simply a matter of specifying a span length and select the type of material. In beam mode, you can also modify other information that will have an effect on the outcome of the results when running the design. In fact, details concerning the deflection limits, service conditions, and treatment factors can easily be specified here in the input. By selecting beam, floor panel, or roof panel, options to conduct a fire design based on the time of the required resistance and protection added becomes available. If you select a Glulam member, the section related to the Glulam will be available. This section is necessary for Glulam to define the appropriate width to calculate the volume factor CV. The width of the Glulam used in the volume factor equation is dependent on the width of the laminations. As Glulam members get wider, they are manufactured using multiple laminations to achieve the required width. The widest lamination width should be used to determine the size factor for the member. The software pre-populates this for you based on default common lamination width, but you may want to check with the manufacturer to confirm what the maximum lamination width actually is and override the input if necessary. Details on the lateral support spacing is also available in the Beam Mode tab. These options are discussed in more detail in video 3 entitled Lateral Stability Option, which is linked in the description of this video.